the different colors here. Hexagon. Okay, now I have
720.
720. Now we could keep going. And each time we add a side, we would add another 180 degrees, right? But we don't want to have to keep adding 180, 180, 180, 180. We want to look for a formula. Okay. Hopefully these names look familiar.
Yeah.
Yes?
I remember memorizing.
You should still have them memorized or review them. Okay. Now so I want to look for a pattern. If there are three sides, of course we know that's one triangle. So the sum of the angle measures was 180. When we had a quadrilateral, we had two triangles. So 2 times 180 gave us 360.
Is it division by 360?
Yeah. Okay, when we had a pentagon, how many triangles did we have? 3. So 3 times 180, 540. Okay. Let's skip down to, let's say it's an octagon.
Oh, yeah.
If there are 8 sides, how many triangles would you think? So it would be 6 times 180. Let's jump down to 10. If there are 10 sides, 8. Right? So we would have 8 times 180. So let's say,
N minus 2.
okay, no matter what, if we have n number of sides, we have n minus 2. So we have n minus 2 times 180 would be the sum of the interior angles. And
Wait, why did you do times 1? Oh.
right, what do we notice? Now you could do all of these. We're not going to bother filling the whole thing in unless you want to. Feel free. But this is our first theorem. We're not going to prove it. We're just going to apply it. Okay, what does n stand for? The number of sides. So if I say 23 sided polygon, then n is 23. So you're going to take, so it's got to have n sides, and s is the sum of the interior angles. That's our formula. Just going to plug it into our calculator. So if we have a 16-sided polygon, what's the sum? 16 minus 2, right? Somebody want to answer that? Why is it minus 2?
That's how many sides it is.
Well, what did we? Right. Okay, remember that whole table thing that we did above? Okay. What was the relationship between the number of sides and the number of triangles?
Oh, there were 2 less.
Less. Okay. What do we get when we multiply 14?
3,500.
Good. Guys. And okay, this one says 8x sided polygon. Okay. So we're going to have 8x minus 2 times 180. So x just means whatever our polygon is, it's a multiple of 8. So we don't know what x is. So we can't make it 6x because we're subtracting 2. We're not subtracting 2x. So all we can really do here is distribute. Okay, so 8x times 180 is 1440x minus 360. Yeah.
Wait, can you scroll up a little bit?
Oh, sure. Did I go too fast?
No.
Yeah, that's all you have to write. All of these are finding the sum. Okay. Now we're going to find the measure of each interior angle. How many sides do we have? 4. So what's the sum of the interior angles here? Yeah, so they all have to add up to, it's a quadrilateral. Listen, quadrilaterals we're going to work with a lot. So just like we work with triangles over and over again and 4 equals 180, we're going to cancel out with quadrilateral. So just remember it's 360. So yeah, what are we gonna do? Add these up? Yeah, we get 6x is equal to 360, so x equals 60. So measure of angle A is 60, B is 120, C 120, and 60. Also, if I were to add all those together, I should end up with 360, which we do. Question? All right. So this is not going to add up to 360 because it's not a quadrilateral. How many sides do we have? 6. Okay, so it's a hexagon. Now, maybe you don't remember off the top of your head what a hexagon adds up to, or do you? So the sum is going to be 6 minus 2 times 180. All right, so what's 4 times 180? 720, so 720. Okay, so the more sides we have, obviously the bigger the sum. Okay, so conveniently, we have 4 of these are equal. So I'm going to just, maybe I'll do 4 times.
Wait, is S X
No, this is representing the sum
the whole thing?
of the whole thing.
Oh, so 4.
So 4 times 9x plus 30, and 2 times 2x.
Wait, why is it can you just write 4?
Sure. I'm just showing the setup, but yeah, you can combine. Right. So I have 4 angles that are 9x plus 30, and 2 angles that are 2x. Okay, so I get what? 36x plus 120. Okay. So we get 40x equals 600. Think 4 into 60. X equals 15. Okay. All right, so J and M are easy, right? 30 and 30. And once we find the other one, okay, 9 times 15 plus 30.
165.
165. So all of these. Okay. So depending on how many sides, it's going to change what they add up to, right? So if I had a heptagon, we would do 7 minus 2 times 180, and then add them all up. What's that? Good. Okay, another review. Vocabulary term, regular. Regular versus irregular. What do we need for regular? Equiangular and equilateral. So just equiangular. Oops. So you can define it like this.
Also, isn't it?
Yeah, it's got to be convex. So a regular polygon has to be convex. You could say all the sides are congruent and all the angles are congruent, or I think it's easier just to say equiangular and equilateral. Okay, so here's an example.
We can't have a regular.
No, impossible. So, and think about it.
It's concave. It's irregular.
Yeah, if I were to have this, look at this angle here. When I have a concave polygon, I end up with an angle that's bigger than 180. It doesn't even make sense. Bless you. Right? From here to here. Do you see how that would go past the 180 mark? So right away I know I can't have something that's equiangular because I would never get a whole bunch of angles that are bigger than 180. So that will never be regular. Okay, let's look at the sun. All right, we have a pentagon, regular pentagon. How would we find one interior angle? Ideas?
Oh.
Well, they all have to.
They all have to be equal. Okay, well, so let's take a triangle, for example.
Just multiply.
A triangle we know is 180 divided by 3, which is 60, 60, and 60. So what would we do for a pentagon?
3 times 180.
Okay, 3 times 180.
5x equals whatever.
So-
Yeah, 5x equals whatever.
So 5 minus 2 times 180 is the sum, which is 540. So all 5 angles have to add up to 540.
5x equals 540.
Okay, so if I take 540
And divided by 5.
and divide by 5,
Uh,
108.
so every.
So all of the angles inside here are each 108. They all have to, if it's regular, they all have to be exactly the same. What do you think if you would have an octagon?
It'll be 6 times 180.
6 times 180 and then divide by 8. What's going to happen the bigger the polygon or the more number of sides, what's going to happen to these angles?
So you're gonna get more. What's it bigger?
Bigger.
So the more sides.
The more sides, the larger the angle becomes in, right?
Wait, really?
Mhm.
Yeah, because it has.
It's going to get, right, a larger and larger sum. So what if I wanted to come up with a formula for one interior angle for a regular polygon? A formula for that. Well, do we have a formula for the sum?
Yeah.
What was that?
S equals.
N minus 2 times 180. And then what do we divide by?
Number of
N,
sides.
the number of sides. Okay. Alec,
How would you cut up the pentagon?
how would I cut it up?
Three lines.
How would I cut it up? So you have to go from one vertex. So pick any one vertex, right? And you would go here and here. Or you could start from this vertex and go here to here. So when we're looking back at that first page of the notes, you have to draw the number. How many triangles did we get? We got 3. Okay, measure. So now I'm giving you the measure of an interior angle. We want to find the number of sides. So I'm giving you 130. So how many sides would a 135 degree interior angle give us? You see what I'm saying? So I'm saying I need to set this equal to n minus 2 times 180. So I'm giving you, right, the interior angle of a regular polygon. I'm telling you it's 135 degrees. So what kind of polygon? Is that a hexagon? Is it a decagon? What kind of? So how would we solve this? Just
Well, you put multiply by n.
okay, we can multiply both sides by n. Or if you like to think of it as putting this over 1 and cross multiplying. Same thing, right? I'd get 135n equals n minus 2 times 180, which I could just distribute on the right side. 135n equals 180n minus 360. Now what? Yeah, you can subtract 180n. And what do we get? We get negative 45n equals negative 360. And so divide. Yep. Okay. Which means it's an octagon. So in an octagon, every interior angle is going to be 135 degrees. Okay, what about 156? Okay, now they're getting pretty big. What's the cutoff? You can never have an angle that's bigger than 180. So that would be impossible. Remember how I talked about the concave? Yeah, all right. Did you get it? Oh, sure.
Wait, so you can't.
Oh, yeah, sure. That's fine with me. Yeah. So here, and also I would just distribute at the same time, like multiply both sides by n and then do 180n minus 360. Oh, you got it already? Yeah, subtract 180 and we get negative 24n equals negative 360. N equals 15. Okay. Question? Good? All right. Oh. That's a good stretch. Okay. All right. Are we good, Ariel? Okay. Exterior angles. Okay, let's examine the sum of the exterior angles. So just to start off, I gave, we're going to use regular polygons as examples. Okay. So start with a triangle. How do we draw an exterior angle? We're just going to extend each side in one direction. So, yes, one direction. So like here, I'll extend that side. Then I'll extend this one. Lovely. And I don't want the exterior angles to crisscross, so I just want to extend one. So kind of like go around like clockwise or counterclockwise.
You didn't answer the question. Who's your favorite out of the...
Okay. What are each interior angle in a regular triangle?
What?
What are the interior, come on, we know this.
I don't... Oh,
60, 60, 60.
Oh, so we want the money.
So each exterior angle is 120, 120, and 120. What is the sum of the exterior angles? 120 plus 120 plus 120.
I don't... Is that 360?
It is 360. Okay. Let's take a look at a regular quadrilateral.
Is it always 360? Wait, so this is a equal, like...
Okay, so let's do a square. So I'll extend this side, this side. And what do we know about squares? All the interior angles are 90, so all the exterior angles are 90. Okay.
Why is that?
What's that? This is 90, this has to be 90. This is 90, this has to be 90. Right? Because these are all linear pair. Just like in the triangle.
How do you know that those are 90 square? Are they always 90?
In a square?
Oh, it's linear.
Okay, what is the sum of the exterior angles? 90 plus 90 plus 90.
Are they all 90?
This one was cool.
What do you think? So
Yes.
next, if we have a hexagon, is it going to change?
Well, it's
So
gonna
no
be
matter
more.
how many sides we have, what's the sum of the exterior angles?
Smaller.
Do you think it's going to be smaller? Well, here, one interior angle would be 120. Right? So the outside ones, so this will be 60, 60, right? And so on. And how many of them do I have? 6 of them?
A little bit more.
Oh, sorry, I jumped to, okay, if it's a hexagon, it would be 6 minus 2 times 180 divided by 6. So 4 times 180 is 720. Divided by 6 gives us 120. That's how we find the interior angle, right? Remember I said if you want to find one interior angle, plug it into the sum and then divide. So we would get 120 for each of these, which means all the exterior angles would be 60, which makes the sum. Okay, so the sum of the interior angles gets bigger and bigger and bigger the more sides we have. But the exterior angles doesn't change. So anytime I say, oh, what's the sum of the exterior angles of a decagon, you're just going to say 360. There's no formula for it. It's just right here, the exterior sum theorem.
So if it's convex.
Yeah, it's got to be convex. It's always going to be,
So if it's a regular
360.
polygon, then it has to be.
okay, it doesn't even matter if it's regular. It's all polygons.
Right.
All convex polygons.
But not every polygon is regular. That's correct. So not all polygons are.
But even if I drew another polygon that was not regular,
But if it was a concave polygon,
then it doesn't apply.
right, so it's not all polygons.
It's all convex polygons. That's why.
Can a polygon be regular and not convex?
Anyone? Can it be?
No.
No.
So then doesn't it mean that all regular polygons?
No. All polygons.
What?
I used the regular polygons as an example, but if I picked another, like if this was 80,
Oh, because regular
this
means
would
that
be
it has to
100.
equal-
Let's say this was 70, this would be 110.
So
It's
all equal. So all
If this was 90,
convex. So all regular polygons are convex, but not all convex polygons are regular.
yeah.
Yes,
Okay.
got it.
All right, you got it. Okay. What if we want to find one exterior angle?
Are we making a theorem thing? Formula?
Well, what's the sum of the angles? And if I just divide by how many sides?
Then
Right.
divide by
Like take a triangle, for example. If all the angles on the outside have to add up to 360, 360 divided by 3 gives us 120.
Isn't it easier to find the exterior angles then?
Yes. Bingo. What do we notice about the interior
Do you
and the
find-
exterior
do you
angles?
find the interior?
What do you
Just look at
interior angle
so much easier.
plus exterior angle always adds up to 180. So Ellen made the observation that isn't it always easier just to do the exterior angle and then you can find the interior angle based on that?
Yeah.
Oh, so much easier. It's just 360 divided by n, and then if you know
You
they
just
add
count
up
the
to
sides,
80.
and then you just.
Okay. The measure of each. So we want to find
Pent is 5.
the exterior and interior.
Pentagon 5.
Pentagon is 5. Okay, so what's one exterior angle?
Oh my god. 360 divided by 5. Wait.
Come on, we can do this.
72.
72. So what would the interior angle equal?
108.
108. Okay. Dodecagon.
What? Is that 12?
12.
Oh my god.
So my exterior angle will be 360 divided by 12, 30. And then my interior angle has to be, wait, 180 minus 30, 150.
That's a really big.
Well, dodecagon has 12 sides, so it makes sense that the bigger the interior angles are going to become.
So the biggest, if you
179.9999 something. Okay. Same thing. I'm just giving you the number of sides. Here, we could do this real quick. So what about a 20-sided polygon?
Whoa, that's a lot of sides.
That is a lot of sides. It's 18 sides, or 18.
So,
Yeah, so it's going to be 360 divided by 20. And we said that was 18 degrees. And our interior angle would then be 162. And then 18. Well, that's kind of easy because it's like just the opposite of this one, right? So exterior will be 20. And then the interior angle will be good.
Do I have to like write interior angle equal, or like I just did the math?
Well, I want to know which one is which, right? So on the homework, if they ask you for an interior and an exterior, I want you to write which one is which, because right, if you have two numbers written down, you need to identify which one's which. All right, we actually have some time.